We are finally ready to start Chapter 3 on differentiation. And so the very first thing we will do in this section in this chapter is section 3.1, in which we will look at the definition of the derivative. So by the end of this video, we will have the definition of what the derivative is, and then the rest of the section will be looking at how to apply the definition in lots of various ways. Okay, so the derivative, as we see, is going to have to deal with tangent lines. So actually, let me just do this right here. So what we're going to talk about when we talk about the derivative is, let's say that right here is some point A here. The derivative is going to have to deal with the slope of this tangent line. So a line that just brushes against this curve at that particular point. So in order to come up with what is our precise definition of this tangent line, we want to talk about secant lines. So let's do that. Okay, so suppose that, let me just draw some axes here, and let me once again draw some curve. And let's pick out a couple of points. Let's say right here is point A, and so let's say right here is point B. So I will draw this point right there is A comma f of A. Guess our function is f of x. Dot, 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 dot. That point there is B comma f of B. And so for any 2 points that are on our function, we can draw a secant line between them. Let me try to draw this as straight as possible. A line through those 2 points. And so this line is called a secant line. And so take a second, think about, I knocked the cap on the floor, so while I pick it up, what's the slope of the secant line? So we've got coordinates for this point, coordinates for this point, so the slope of the secant line is quite easy for us to compute. It's just going to be the change in the y coordinates, which is f of b, minus f of a, over the change in the x coordinates, which is b minus a. So this is our slope of the secant line. In this particular case, well, what happens if we change our point from this b to some other point? So let me call this, now I'm going to think of this x as a point that can move here. So right now, this point is, coordinates here, x, f of x. Once again, we can draw a secant line between those 2 points, with the slope being f of x minus f of a over x minus a. And so this difference quotient, that's a term that we want to use here. So as we take this, as we take x to be closer and closer and closer to a, our slope is going to get slope of the secant line, which is this different quotient, is going to get closer and closer and closer to the slope of the actual tangent line here. So we can think of this difference quotient, the slope of the secant line, as approximating the slope of the tangent line. Well, guess what? When we're thinking about moving our point X closer and closer to A to get better approximations, well, that should sound familiar. That should sound exactly like something that we've been doing in chapter 2, which is we're basically taking the limit of this difference quotient as x gets close to A. So really what we're doing here is that we are thinking about what is the limit as x goes to A of f of x minus f of A over x minus A. And this is exactly what the definition of the derivative is going to be. So, f prime of A, we want this to be when we've plugged in the value A here. So A we're thinking of a particular number, A we're thinking like what's the derivative, what is f prime of 7 or something like that. There's another way to write this that I think is the textbook's preferred method, or it looks like the textbook likes them both equally, which basically what happens is that we replace this x with a plus h. So it's a plus however far we have to go to the right here. So x is we just rewrite as a plus h, and so then we end up with the slope of let me go back to this slide here. The slope in this case is f of a plus h minus f of a, all of that over a plus h minus a. And so this has the nice feature that the denominator simplifies to a plus h minus a. It simplifies to h. So the limit as h goes to 0 of f of a plus h minus f of a, all of that over h. So this is kind of sloppy here, so let me just make up one final slide for this video in which I just carefully write down what the definition of the derivative is. So here is our definition of the derivative. And so this is the derivative of a function f at a point A is the limit of the difference quotients, f prime of A, so there's a little, so we call that little mark there, a little single quote mark, a little apostrophe there, f prime of A is the limit as x goes to A of f of x minus f of A over x minus A. Or equivalently, it's the limit as h goes to 0 of f of a plus h minus f of a over h. So, and we should say here that if these limits exist, we say f is differentiable at x is equal to a. So this is our single most important definition in the course. You know, everything that we'll do from here on out basically is going to deal with a derivative in one way or another. This also shows why we spent so much time in Chapter 2 talking about limits, because our most important definition here is going to be in terms of limits. So now we're going to, all throughout Chapter 3, we're going to use the limit stuff that we did in Chapter 2 to talk about these particular limits. Okay.